Hi guys, welcome back. Myself Rakshit, and today's topic is about Raspberry Pi, a comprehensive guide to building a wireless temperature monitoring system. Let us see about introduction. In this presentation, we will explore how to build a wireless temperature monitoring system using Raspberry Pi and sensors. The Raspberry Pi is a credit card size single board computer developed by the Raspberry Pi Foundation in the United Kingdom. It was first introduced in 2012 with the aim of promoting computer science education and making computing more accessible to people around the world, particularly in developing countries. Let us know what is Raspberry Pi. The Raspberry Pi is an all affordable computer that can be used for a wide range of projects like popular for its versatility, low cost and ease of use. With its GPIO pins, it's perfect for connecting sensors and creating customizable electronic projects. In Raspberry Pi, the hardware components like the Raspberry Pi typically consist of a system on chip with an ARM-based CPU, RAM, GPU, input or output pins, and USB ports, HDMI output, Ethernet output on some models, Wi-Fi and Bluetooth connectivity, and a micro SD card slot for more storage. Operating system. It can run various operating systems including official distributions of Linux such as Raspbian, now called as Raspberry Pi OS, as well as other Linux based distributions like Ubuntu and even Windows 10 IoT Core. Usage. The Raspberry Pi can be used for a wide range of applications including but not limited to education like education, teaching, programming, electronics and computer science, home automation, controlling smart home devices, and media center like running media player software to stream content, retro gaming, emulating classic video game consoles, robotics, building and controlling robots, IoT projects as creating connected devices and sensors, server hosting, running web servers, file servers, etc. Let us see more about wireless temperature monitoring. Using Raspberry Pi and wireless communication modules, we can create a system to remote monitor temperatures. This allows for real-time data collection and analysis, making it ideal for applications such as home automation, agriculture, and industrial monitoring. Wireless temperature monitoring with the Raspberry Pi is a popular project that utilizes the Pi's GPIO pins, a temperature sensor, and wireless connectivity options like Wi-Fi or Bluetooth. Choose a temperature sensor. There are various temperature sensors compatible with the Raspberry Pi such as the DS18B20 or DHT series. Choose one based on your requirements and preferences. Wireless communication. Decide on the wireless communication method you want to use for transmitting temperature data. You can either use Wi-Fi to send data to a server or cloud service, or Bluetooth to transmit data to a nearby device. Selecting the appropriate temperature sensors is crucial for accurate monitoring. We will discuss different types of temperature sensors, including digital and analog sensors, and how to integrate them with the Raspberry Pi. Sending data wirelessly. Implement the code to transmit temperature data wirelessly. If using Wi-Fi, you can use libraries like requests or MQTT to send data to a server or IoT platform. If using Bluetooth, you can use libraries like PyBlues for Bluetooth communications. Let us see about setting up Raspberry Pi. Initial setup of the Raspberry Pi including installing the operating system, connecting to Wi-Fi and configuring the GPIO pins. We will also explore the use of Python for programming the temperature monitoring system. Get the hardware. Raspberry Pi board. Choose the model that fits for your needs. Micro SD card 8 GB or larger recommended. Power supply micro USB or for most models. HDMI cable if you have planned to connect to a display. Keyboard and mouse optional if you are not using SSH. Download the operating system OS. Visit the official Raspberry Pi website or a reputable source to download the desired OS image. Raspberry Pi OS is the official OS and is widely used. If you are unsure which OS to choose, Raspberry Pi OS is a good starting point for beginners. Flash the OS onto the micro SD card. Use a tool like HR available for Windows, Mac OS and Linux to flash the OS image into the micro SD card. Follow the instructions provided by the tool. Make sure to safely eject the micro SD card from your computer once the flashing process is complete. Insert the micro SD card and boot up. Insert the micro SD card into the Raspberry Pi's card slot. Connect the HDMI cable to a display, the keyboard and mouse to the USB ports, and the power supply to boot up the Raspberry Pi. Follow the on-screen instructions to complete the initial setup process. Configure the system. Once the Raspberry Pi boots up, you will be promoted to configure the system settings, including setting a password for the default user using Pi, configuring the Wi-Fi network, expanding the file system to utilize the full capacity of the micro SD card. You can access the configuration menu at any time later by running sudo raspi configuration in the terminal. Building the monitoring system. We will guide you through the process of connecting the temperature sensors to the Raspberry Pi and connecting a set and setting up the wireless communication. This will involve writing code to read sensor data and transmit it wirelessly to a central monitoring system. Configuration to programming. Configuring your Raspberry Pi for programming involves setting up the necessary software development tools, environments, and libraries to write and execute code on the device. Choose a programming language. Decide which programming languages you want to use on your Raspberry Pi. Common choices including Python, C or C++, Java, and JavaScript, among others. Python is especially popular due to its simplicity and versatility. Install a text editor or IDE. Choose a text editor or integrated development environment for writing your code. Some popular options include Nano, a simple text editor available in the terminal, Visual Studio Code, a versatile IDE with extensive features and extension support, Thorny, a beginner-friendly Python integrated development environment included with Raspberry Pi OS. Ideally, another Python IDE included with Raspberry Pi OS. The more about configuration to programming is installation, the necessary language, runtimes and topic tools. Depending on the programming language you have chosen, install the corresponding runtime and development tools. For example, for Python is sudo apt install python 3 python 3 -pip. For C or C++, sudo apt install build essential. For Java, sudo apt install default JDK. For JavaScript, sudo apt install node.js npm. Install additional libraries or frameworks. Depending on your specific programming needs, you may need to install additional libraries or frameworks. Use pip for Python packages and your distributions package manager for other languages. Data visualization and analysis. Once the temperature data is collected, we will explore methods for visualizing and analyzing the data using Raspberry Pi. This will include creating graph settings, up alerts, and storing data for long-term analysis. Choose your analysis tool. There are various tools and libraries available for data analysis on the Raspberry Pi, including Python libraries like Pandas, NumPy, and Matplotlib. These libraries provide functionalities for data manipulation, numerical computations, and visualization. Remote access and control. In this slide, we will discuss how to access and control the temperature monitoring system remotely. This involves setting up secure access to the Raspberry Pi and implementing control mechanism for adjusting monitoring Parameters. Challenges and solutions. We will address common challenges encountered when building a wireless temperature monitoring system with Raspberry Pi, such as power management, signal inference, and data security. Solutions and the best practice will be shared. Conclusion. We hope this presentation has inspired you to explore the exciting possibilities of IoT and DIY electronic projects. Thank you.